Hi, this screencast is on finding the number of moles in a particular substance and converting it, and then also finding the molar mass. Alright, so relating the mass to the number of atoms is done with a unit called the mole. Mole is the unit of amount of substance, and we abbreviate it as MOL, or you can write out the whole thing as MOLE. It is kind of like a dozen. It describes the number of pieces in a sample, and like a dozen, it has a specific number. So if I told you I needed a dozen donuts, you would go and get me 12. All right. Well, the number that is associated with mole is Avogadro's number, and Avogadro's number is 6.0221415 times 10 to the 23rd. You're only going to need to remember about 6.02 times 10 to the 23rd. That is what we're going to work with whenever we're converting between moles and particles. Okay, so the particles that we can assign to this number are atoms, ions, molecules, and formula units. So any of those can be 6.02 times 10 to the 23rd atoms in 1 mole. Okay, so if I send you to the bakery and I ask you to get me a dozen donuts, I can send you to the lab and ask you to get me a mole of atoms, and you should come back with 6.02 times 10 to the 23rd atoms of that substance. Okay, molar mass is the mass of 1 mole of any substance. So if I were asking you to get me a mole of copper on the periodic table, you can see that a mole has, if you look on the periodic table, you can see that copper has a mass of 63, almost 64 grams. So if I asked you to get me 1 mole of that substance, you could come back with 6.02 times 10 to the 23rd atoms for 1 mole of copper, or you could come back with the atomic mass, which is 63.5 grams of copper. Okay, so we're going to relate molar mass to mole. It is, when we find molar mass, it is grams per mole, and you're going to add up all the atomic masses of the substance you're being requested to find. It's pretty simple when it's an element. When it's a compound, it's a little more complex. So if we're dealing with water, water is made up of H2O. So here's 2 different graphics showing you the same thing essentially. In the top graphic, you can see the red dot is what they're saying is oxygen, and the 2 black dots are hydrogen. So in order to figure out the molar mass of H2O, you find the mass of that oxygen, and then you find the mass of those 2 hydrogens, and you add them all up together. And the bottom is how you can do it mathematically. You see that there's 2 H's, so 2 times the mass of hydrogen, and 1 O, so 1 times the mass of the oxygen. And you multiply them across, and you add down, and you get 18. Water's molar mass is understood to be about 18.0 grams per mole. Okay, depending on your teacher is how many tenths place or hundredths place you're going to round to whenever you're dealing with masses from the periodic table. Typically in class, if you round to the whole number, you'll be fine. If you're taking the AP exam, you probably should round to the tenths place. So how do you find the molar mass? Okay, here's another example. C6H12O6. We recognize from the compound the 6 means that there's 6 carbons, the 12 means that there's 12 hydrogens, and then there's 6 oxygens. So you look up the mass of the carbon, the hydrogen, and the oxygen, and you multiply them by their subscripted number, and you add those final answers up, and you end up getting your molar mass for C6H12O6. So if you look at the right column under mass, you see 6 times 12, you see 12 times 1, and you see 6 times 16, and you get the resulting numbers, and you add them together, and you get 180 grams. So here's an example. This is probably one of the harder ones, but it is not hard. You have Ca3PO4 in parentheses 2. Okay, so to break it down, the first step you're going to do is identify what elements you have. There's calcium, there's phosphorus, and there's oxygen. Okay, how many calcium do you have? Well, there's a 3 there, so you have 3 calcium. How many phosphorus? Now this is where the parentheses comes into play. The parentheses, just like in math, means that you distribute the number right outside of it if there's no math function. So that 2 is directly outside the parentheses, so it will distribute to both the P and the O. So for our P, we have 2. For our O, we now have 4 times 2, so 8. Looking up on the periodic table, calcium has a molar mass in a whole number form of 40. Phosphorus has a whole number form of 31, and oxygen has a whole number form of 16. So you multiply them across, you add them up, and you end up getting 310 grams per mole is the molar mass of Ca3PO4 in parentheses 2. Okay, take it step by step, break it down. First, write down what elements you have, how many of each element you have, look up the molar mass, multiply, and then add, and that will help you find the molar mass for your element.